This is Earth. What if we could rewind time and revisit the past? Billions of years ago, in the vast expanse of the cosmos, a swirling cloud of gas and dust coalesced into a small, rocky planet orbiting a young star we now call the Sun. Over eons, this planet underwent tumultuous transformations, from molten lava to a hospitable environment teeming with life. How do we get from then to now? Discover the secrets hidden in our planet's primordial past as we journey through time.
In the fiery crucible of the Hadean Aeon, Earth was a hostile world engulfed in chaos. Lasting from about 4.6 to 4 billion years ago, this tumultuous era was defined by searing temperatures, relentless volcanic activity, and frequent bombardment by asteroids and comets. The planet's surface was a rolling sea of molten rock, devoid of any semblance of life as we know it today. Despite the harsh conditions, the seeds of our planet's future were sown during this tumultuous epoch, as the early Earth began to cool and solidify, laying the foundation for the eventual emergence of oceans, continents, and the complex ecosystems that would come to define our world.
During the Archean Aeon, started 4 to 2.5 billion years ago, transitioning into the Proterozoic Aeon. Earth underwent significant geological and biological changes. Volcanic activity shaped the landscape, while gases like methane and carbon dioxide dominated the atmosphere. In the planet's ancient ocean and hydrothermal vent, simple prokaryotic organisms emerged, release oxygen through photosynthesis and paving the way for more complex life forms. This period marked the beginning of life on Earth and set the stage for subsequent evolution, laying the foundation for the diverse biosphere we see today.
The longest geological aeon began 2.5 billion years and ended 541 million years ago. The Proterozoic Aeon was marked by a progressive increase in atmospheric oxygen, caused by newly evolved cyanobacteria with photosynthetic capabilities. The huge extinction of anaerobes causes a rapid increase in oxygen, which is known as the Great Oxygenation Event.
Unicellular eukaryotes evolved during the Proterozoic Aeon as well. These single-cell organisms have nuclei and organelles, such as mitochondria and chloroplasts.
The Phanerozoic Aeon, spanning approximately 541 million years to the present day, is characterized by a remarkable diversity of life forms and geological transformations. Throughout the Phanerozoic, Earth's climate fluctuated, continents shifted, and life continuously adapted, showcasing the dynamic and ever-changing nature of our planet's history. The Phanerozoic is divided into three eras: the Paleozoic, Mesozoic, and Cenozoic.
The Paleozoic era started 530 million years ago and lasted 289 million years. It all began with microbes in the oceans. Soon, land masses merged into a supercontinent and an ice age spread across the globe. Jawless fish, algae, sponges, and the first plants appeared. Later, continents collided, forming three supercontinents. Plants covered the world, and insects with wingspans of 75 centimeters lived. Sharks were the top predators in the oceans. The Paleozoic era ended with the creation of the supercontinent Pangaea, which stretched from pole to pole. The Paleozoic era also had the highest extinction rate ever known, with 96% of all life on Earth dying.
Over the ages, which lasted from approximately 541 to 485 million years ago, leaves a pivotal mark in the Earth's history, the Cambrian period. The Cambrian explosion has become a subject for the scientists as to what has caused it. It was during this time that the diversity of life on Earth experienced a rapid and dramatic increase that led the scientists to conclude that it may be because of the new oxygen and new habitats that made life change and grow quickly. Additionally, it significantly shows that the group of animals we see up until this day started during the Cambrian explosion, such as trilobites, anomalocarids, brachiopods, and early forms of arthropods and mollusks. Lastly, this is where I end the remarkable chapter in Earth's history, the Cambrian period. A time where the evolution of different kinds of species and a time where the life first started. However, the story of the Paleozoic era has only just begun.
New species emerged as a result of widespread change on Earth. The Ordovician period that occurred between 488.3 million to 443.7 million years ago is most renowned for its numerous marine invertebrates, which include graptolites, trilobites, brachiopods, and conodonts. All creatures at the time were distinct from those that live now. The ocean contained the vast majority of all life. Conodonts with tiny teeth and huge eyes, brachiopods, a shell-like animal, and trilobites were also abundant, and many more creatures. These organisms obtained their food by sucking and filtering it from beneath them.
During the Silurian period, spanning from approximately 443 to 419 million years ago, Earth experienced a transformative chapter in its history. The continents were undergoing significant changes, gradually shifting and merging into supercontinents such as Gondwana and Laurasia. This period witnessed the emergence of jawed fish, including the iconic armored fish known as placoderms, alongside the early ancestors of modern vertebrates. The Silurian period marked a pivotal juncture in the evolution of life, as organisms adapted to new environments and ecosystems flourished in ancient seas and emerging terrestrial realms.
The Devonian period, spanning from approximately 419 to 359 million years ago, was a pivotal chapter in Earth history known as the Age of Fishes. It witnessed the evolution and diversification of various marine and terrestrial life forms. In the ocean, jawfish become increasingly dominant, with some evolving into early shark and other developing bony plates, precursor to modern bony fish. The Devonian also saw the emerge of the first tetrapods, vertebrates capable of living both in water and on land, marking a significant steps in the transition from aquatic to terrestrial life. The Devonian period laid the foundation for the evolution of complex ecosystems and set the stage for the colonization of land by vertebrates.
Entering in the Carboniferous period, approximately 359 to 299 million years ago, Earth was a vastly different place. The Carboniferous period was marked by the different species and organisms that have evolved and was made as this period came. The volcanic eruptions have sculpted the lands that created new opportunities for life on Earth to survive. The soaring trees and abundant greenery has dominated the wide landscapes. It was an age of giants. Various organisms we never expect have ruled both land and skies, significantly insects and early amphibians, as they explored through the damp forest floor and adapt the life through land. And so, the Carboniferous period was a time of transformation, passing and leaving behind a rich legacy for the future generations of the lives on Earth to uncover.
The Permian period was the last period of the Paleozoic era, lasting from 299 million to 252 million years ago. During this period, the supercontinent Pangaea comprised nearly all of Earth's land masses. The period began with a cold climate that later turned much warmer and drier. This climate led to the extinction of giant insects and terrestrial arthropods. Reefs and many other life forms filled with seas in the Permian period. The period ended with the largest mass extinction of all time, caused by factors like volcanic activity.
The Mesozoic era, spanning for approximately 252 to 66 million years ago, is often referred to as the Age of Reptiles. It is divided into three periods: the Triassic, Jurassic, and Cretaceous. During this time, Earth underwent significant geological and biological transformations. Earth's history during the Mesozoic era had marked several significant events, such as the breakup of Pangaea, rise of dinosaurs, evolution of light, mass extinctions, expansion of marine life, the continental drift, and evolution of mammals. The Mesozoic era ended with the Cretaceous Paleogene extinction event, which wiped out land avian dinosaurs along with many other plankton animal species. This paved the way for the rise of the mammals and the eventual emergence of the modern Maiutervicid. The Triassic period, spanning from approximately 252 to 201 million years ago, marked the dawn of the Mesozoic era. It was a time of profound change, characterized by significant geological and biological events. In terms of geological shifts, the Triassic saw the breakup of the supercontinent Pangaea, leading to the formation of separate land masses. Dinosaurs emerged and began to diversify, first mammals appeared, and marine life flourished. The Triassic-Jurassic boundary was marked by several significant extinction events. Though not as severe as the Permian Triassic event, these events may have been caused by volcanic activity or other environmental changes.
After the Triassic period's great extinction, the Jurassic period started. The Jurassic period, also referred to as the Golden Age of dinosaurs, experienced an increasing dinosaur population. It gave dinosaurs a numerous number of new roles to fill. The earliest bird originated from dinosaur ancestors throughout the Jurassic period as well. All of the major groups of mammals evolved, although they were all small in size. Flowering plants appeared for the first time, and new insects evolved to pollinate flowers. About 65.5 million years ago, the dinosaurs of the Mesozoic era went extinct, causing the start of the Cenozoic era. Mammals were able to thrive because of the terrible extinction event that ended the Cretaceous period and killed out the dinosaurs. The era in Earth's history when mammals started taking over is referred to as the Age of Mammals. The development of humanity was preceded by the extinction of species like the saber-toothed tiger and the woolly mammoth.